Hello, respected judges. Welcome to my presentation. I am Devan Muhammad Sunan from Bangladesh. So, today my topic is probability. Now, what is probability? Probability is the way of expressing knowledge of belief that an event will occur on Earth. It means probability says us what will be the chance of occurring, what will the chances of occurring an event in an experiment. And also, probability originates from the Latin word meaning approval. Now, we will talk about probability in brief. You know that probability is a branch of math and it also studies about the patterns of chances occurring in an event. The idea of probability is based on the observation, and also probability describes what happens over many after trials. Now we will learn about definition of probability. Probability is the measure of how likely it is that some event will occur, a number expressing the ratio of favorable cases to the whole number of cases possible. Okay, well, I will tell in an easy way that probability measure what will be the what will the chances of event occur when which and it will be expressed like a ratio of favorable cases and also ratio of the favorable cases and whole numbers of cases. For example, suppose you toss a coin and there will be 50% chance for getting a tail and 50% chance for getting a head. So that's the definition of probability. Now we are moving to definition of probability in theoretical way. Suppose you have an event P E. So probability of E is equal to number of favorable outcomes divided by total number of outcomes. It means suppose you have toss a coin and its total outcome will be two heads or tails. So two, and you want heads. So the favorable outcome will be one. So the answer will be half. So it will be this will be the probability for tossing a one coin. Now, definition of experimental probability. What is experimental probability? Experimental probability is a chance of something happening based on repeated testing and observing results. It means that when we repeated testing and observing any results and the probably which probability comes out is known as experimental probability. For example, to find a probability of getting 6 when rolling a dice, you need to roll the dice many times. Then divide the number of times you roll the 6 with how many times you roll the dice. We have seen in previous slides. Now, when any question arises, something happening, any question related to the chance of something happening, we can use probability because probability is the easiest way to solve that. Now, there are some common factors related to probability. I will go one by one. The first factor is experiment. Experiment is a situation involving chance or probability that leads to results called outcomes. I will try an easy way that experiments. Suppose you're tossing a coin, it's an experiment. Suppose you roll a dice, you roll two dice, three dice, it will be an experiment. And after rolling a dice, what will be the outcome? Suppose you roll a dice and it comes three, you roll a dice comes four. Then it will be the outcome of that experiment. And equally likely outcome is suppose you have two events, a dice and a coin. You have two dices. So suppose you roll two dices. So from here you can get like one, two, or three, and from also in second dice you can one to ten. If the probability get matched, then they will call equally likely outcome. Now there are also some common probability related factors like sample space, event, and sample point. So sample space is the set of outcomes coming of an experiment. Like suppose you roll a dice and their sample is 1, 2, 3, 4, 5, 6. Because there it will be total 6 outcomes, which 1 to 6. Event. Event is one or more outcomes in an experiment. So events will be one or more outcomes in an experiment. Like suppose you roll a dice and then you got 6 outcomes, and here you can each this roll and dice will be an experiment because event because it has more than one outcomes or a sample point. Each of the element present in a sample space is known as sample point. Suppose you have roll a dice, you have 1, 2, 3, 4, 5, 6, and each like 1 will be a sample point, 2 will be a sample point. Easy things. Now we have to remember some key points. Like number one, I mentioned that probability of any events they will be calculated by the number of times that desired outcome occurs and divided by the total number of trials. And then events are independent if outcome one event does not influence the other outcome. Acha. So events will be independent if the both outcomes will be not influence any other. Events are mutually exclusive if they cannot occur. So I will talk to that about later slides. I have there. Addition, and there is a important rule, is addition rule. If you want to get probability of A or B events, so then we have to plus probability of A plus probability of B and minus probability of A and B. Now there is a comparison probability for A versus B, and you have to remember that probability of, if probability of A, suppose you have probability A and B, and if probability of A is greater than probability of B, then A is more likely to occur. Suppose your probability of A is half and probability of B is 1 by 4, which is greater? Obviously probability of half, and it has more chances to occur. And now if probability of A equal to probability of B, then it will be equally likely, because I have told that before. Now there are some types of events you can talk. First event is simple event. If an event E has only sample point in sample space, it is called a simple or elementary event. Suppose you have an event and it has only outcome one, then it will be simple because it has only one outcome. Compound event. If an event has more than one sample point, it is called compound event. Suppose you toss a coin, you have two outcomes. Then it will be compound because it has more than one outcomes. Then we move into mutually exclusive events, which I have told that the two events are mutually exclusive if the occurrence of any one excludes the occurrence of other. That is, they cannot occur simultaneously. Suppose you have events outcomes 1, 3, 5, and another event occurs 3, 2, 4, 6. They can occur simultaneously. If they occur simultaneously, they will be not mutually exclusive events. But if they don't occur simultaneously, they will be mutually exclusive events. What is exhaustive events? I've told in a simple way that when at when suppose you have events like E1 to N events, then if any of the events need to be occur, but it has necessary and it is mandatory to occur, then it will be known as exhaustive events. Then there's an example spinner. You see that here are spinner which is four colors. So I have to know which color will be. I don't know. Then I have to make a probability. Then suppose I want red. So in spinner there the probability is 1 by 4 because I have total 4 outcomes and I want red. So it has only one favorable outcome. So it will 1 by 4. Here example for dice. You know dice is sample space 1 to 6, 1, 2, 3, 4, 5, 6. So each number of a dice have probability 1 by 6 because its favorable outcome is 6, and which number I want will be its only one sample person, 1 by 6. And if we want to find the probability of even digits, there will be 3 by 6 because there are total 3 digits in 1 to 6 and 3 odd digits in 1 to 6. So it will be 1 by 3. Now, there are some general rules we have to follow in probability. Probability number probability came should be in 0 to 1. If they exist, there will be no probability. Then the sum of probabilities will be the sum of all probabilities. The sum of probabilities of all samples will be 1. And the probability that doesn't occur will be -1. The probability that does occur is also called complement of A. Now, there are also some rules we have to remember that probability of sure event, and you know that it will be occur and you very confident that it will be 1 and it's sure to be occur. A probability impossible that cannot be occur will be 0. Now there are some counting techniques that if we want to make if we have two events, like we have a coin and a die, so we have to make the ways so we can multiply the favorable outcomes so we can get the possible outcomes. And here is you can see a probability of coin and a dice. And where now at last we can see that where we use probability. Probability you use in various ways in our life. Like you can use in gambling, finance, in artificial intelligence, math, etc. And there's a quiz for you. Suppose you have 40 candies, 26 are red, 4 are blue, and 10 are yellow. And you have to take one. And there are some questions like, what is the probability of getting red candy? It will be 13 by 20 because we have 26 and you get 13. So that's a way. Like this way, probability of getting yellow 1 by 4. What is the probability of getting blue candy 1 by 10? This is some simple questions. And that's all of my presentation. Thank you for being with me, and thank you for please have a nice day.